Hello everyone, here is a Taito Space Invaders power supply. I suppose this is in the early cocktail table maybe, or it's in the early stand-up. I don't know. I really don't know. It came in with a board set repair. I've got the board set done, and now I'm doing the power supply. And the way that this works, it gets a rectified and filtered unregulated 5 volts for an input, but the other voltage inputs are rectified on board and filtered on board. So only the 5 volts is a filtered DC, is a rectified and filtered DC. And you can see that. That's the schematic. You can actually see it right here. Let's do this. You have 9 volts on either side, so it's a span of 18 volts, which is single wave rectified. No. Double. It's just not. It doesn't have a negative out of it, but that's double. That is full wave. And then you have your filter here, 22,000 microfarad filter, and then that is sent to the board through right here. But yeah, that is. I was. What confused me, what threw me off is it's not a bridge rectifier, so it doesn't have a ground off of it. It's using the center tap as a ground. Well, I went about it different. I used a bridge. I had to build this circuit for this. I just built a bridge right there, and I have wires going off of it here to this filter. Now this is a 56,000 microfarad filter, so that's filtering off of this, and I'm just using 2 taps off of this. I'm using the 0 volts and a 9 volt. So instead of using the center tap and then the 2 9s, I'm only using the center tap and a 9. And then I'm running that over to that. And this is where I'm creating my negative on this. And then I'm sending the 2 positives over to this. Or not the 2 positives. I got my ground here. The green wire is the ground, and then the orange wire is my positive voltage. So if you don't have that's pretty warm. It's loaded. It's under load, so it's creating some heat. So I got my filtered voltage coming over into here. I've got load right here. That's the load. It's about 3.5 amp load. You can see it's plugged in right there, and we're at 4.98 volts is where I set it, right under 5 volts. So that is working just fine. Now the way this works for the other voltages is they're rectified on board. So I just have to run straight AC right off of the transformer over to here for the other voltages. So I'll do that. But for the rectified 5 volts or the regulated 5 volts, I had to build this circuit. But I've replaced all the regulators, and it's using a 7805 to regulate the 5 volts. And this part was bad. It's a 3055, basically equivalent. So I replaced that. It was no good. I replaced, there's 2 12-volt 7812s, and then there's a 7905. So I replaced all of those. I removed the transistors and I checked them. They were all good, so I just put them back in. I replaced all the electrolytic capacitors. I replaced the 555 timer, and these 270 ohm resistors right here that I had TP'd right there, And right there, those are 270 ohm resistors that were kind of cooked. And I didn't have 270 ohm half watt resistors, so I just used 2 in series to make 270 ohms. And those are these guys right here, 270 right here and 270 right here. So those two guys in those two circuits got really kind of cooked, so they were still good. They weren't bad, but they were just hot and cooked, so I replaced them. I resoldered everything on the back. I cleaned the back up really well because it was pretty nasty. So this thing is good to go now. Yeah, I resoldered all these connections really good. So I'm going to go ahead and test the other voltages. And that'll do it for this power supply. Alright, now I'm going to test the reset circuit. And from looking at the schematic, and we'll go over that, it looks like I need to have my 5-volt circuit hooked up. So I've got the 5-volt unregulated power, rectified but unregulated, coming in, and I have AC coming in because it looks like you need AC for this circuit. If you look at this schematic, the 5-volt output, we do have 5 volts on pins 1, 2, 3, 4, and 5. That's 5 volts, and it comes over and it powers the IC, VCC. Now, pins 1 and 2 are AC from right here. And I've got a note here, it says 1 and 2 powers the reset circuit, plus it outputs 18 volts unregulated on connector 9 of this. And I've got that loaded just to make sure it works. I've got it loaded with this. So we will power it up. Yeah, 1 and 2 comes up and goes to this bridge, and the output of that bridge comes up over here and goes over through a diode right here, and that looks like it supplies current to that trigger input. And then this little biasing here. So that's what we need for operating this. So what I will do is grab something to pop on here like that. I'll go ahead and put this on here and then just grab pin 3. And then we'll watch this. It'll go up. It should start up and then go down. It'll do this. And that's a proper reset. So we'll go ahead and fire it up. And you see how it does that? And you can see that that capacitor is holding such a charge that it keeps that thing pretty charged up. I just shorted it. I just shorted the cap to kill that power. Now we'll do it again. It'll flash up and then back down really quick. 1, 2, 3. Yeah. Turn it off. It goes up because of the voltage stored in the cap. It's keeping it up there. I'll turn it on the count of 3, and you'll just see that line drop. 1, 2, 3. There we go. Actually, it dropped and then it flashed back up and reset. We'll do that again. You'll see it. It'll drop and then it'll flash up and then back down. Count of 3. 1, 2, 3. There you go. That's a proper reset. So that circuit works good. go ahead and move on to the next circuit. I still have to do the -5 and the +12 tests, so we'll set up for that. I can get rid of my 5-volt circuit now. I don't need that for, don't believe I need the 5-volt circuit for these 12-volt and -5 circuits. The -5 circuit actually works off of the -12 circuit. So this thing makes -12, and then that is regulated down to -5. We'll go ahead and check that stuff. Okay, I have moved my AC input over to pins 3 and 5, which I've got my note here. 3 and 5 is the -12 and -5 supply. We don't really care about -12 because that's not used by the game. We're just checking -5, and I have -5 loaded with that, and we have -5 right on the money. So -5 is good. So all I need to do now is check the 12 volts. And 12 volts is, I gotta use pins 9 and 11 on this. So I'll hook my AC up to pins 9 and 11. And then 12 volts right here is pin 2. Pin 2 of this guy is 12 volts. So we'll move all of that and get this thing tested for 12 volts. Okay, moved over to pins 9 and 11? Yeah, 9 and 11 on the AC input. And I'm using my 16.5 and 0 volt 0 to 6, 0 on one lug and 16.5 on the other is the AC that I'm putting in here. You can see on this right here, it has 0 to 14, sorry, 0 to 14 volts, 0 to 16, and 0 to 17. So I'm just using 16 for all of them. Something was shaking my house. There was a car that went kind of nearby with the bass roar, and it shook my house, and for a second I thought it was this power supply. But it's good, 12 volts. And it is loaded with this, once again. It puts about an amp of draw on it. 1207. So that's all the voltages that we care about, and our reset circuit works. So this thing's good to go. Rebuilt power supply. That's it. This is the Taito. What is this? AA something or other. It's not on here. I don't see it. Looks like this thing was redone on 2010. August 19th of 2010. There it is. AA017741. Space Invaders power supply. There you go. You know what, I do have this current limited as well, but it's not limiting any current, you can see, because my bulbs aren't lit at all. I'll just bypass it. And yeah. There you go. If I want to bypass and actually current limit, I can just, but with this supply, I always start off, when I'm doing supplies, I always start off current limited in case something is shorted or something like that. But yeah, this thing's good to go. So there you go. Power supply. Space Invaders. Done. It's going to do it for this one. Nice quick little video just demonstrating this power supply and the setup that I had to come up with to be able to test this. I'm using my just old transformer. That's an old Midway transformer. And it just puts out good voltages that I can use. I got multiple taps hooked off of it, and I'm able to just tap into it and test everything like that. So there you go. All right, guys, we'll see you all on the next Classic Arcade Repair. Bye for now.